Alright, so I'm putting together this calculator that I got. It's from Spikenzielabs, but I bought it from Adafruit Industries. So this is the calculator. I've got the buttons, the processor, the caps, and some of the resistors already pushed through, and these are the display. So I'm going to solder these up and make sure these buttons are all pushed down, and then I'm going to solder these puppies in. Yeah, this is a good basic kit to start on. You can't really do anything wrong with it. It took me a little bit longer to figure out how to put the case together, because it has a lot of pieces, little pieces that need to be put together right in the right order. So this has a total of, I think, 17 buttons, and all the resistors are all 10Ks, and all the caps are the same. You can't really, there's nothing polarized. The only thing I do is put the chip in right and the LEDs. And there's pretty good documentation on their website. And if you buy from Adafruit, I think they have links on there to it. And yeah, it's a nice little kit. It's got a nice case, like I said. It's laser cut. It all comes together. So that's the last. These are the 2 rows that I put in, and I got 2 more plus the one on top for the on-off. Well, it's nice that they carried the Adafruit, because I don't think I bought anything from these guys directly from their site, so I like going to Adafruit Industries. Even if you order it and it comes through the regular post, you can expect to see it pretty quick. I'm going to solder these in real quick. So that I can get their leads out. Alright, let me cut some of these off. Okay. A couple of these are, clean them up. Okay. So as you can see, I've got most of these already soldered. So I'm going to do the last row here. Okay. Alright, so that takes care of the buttons. They're all pretty good laying down. I'm gonna think there's this one right here. Push on it. It's a little loose when I put it in. It needs more. Okay. Still needs more. Push on this side. Okay. And I'm just going to put the rest of these resistors in. Like I said, they're all 10K. This one needs to be bent a little bit better. Okay. Let's solder these in. Okay. I put the last two in. Okay. They don't have the right spacing on these. You have to bend them a little bit more. So they just want to fit in there. Okay. You can always push them down later and solder them a little, resolder them in there. Okay, trim these. Okay. Let me see about pushing these in a little bit more. Yeah, those are really tight. They just fit in there. But they're good enough. It's not, even though the case is clear and you'll see them, I think they'll be alright. Alright, let's trim off this. Let's push through this a little bit. Okay. That's pretty good. So, if you look, all the buttons have been soldered in, and a piece of solder here. Okay, and the resistors. The resistors and the capacitors. So now, I'm going to do this, these 6 LEDs. They're covered up with painter's tape to make them flush on the top and the sides. They recommend it. It has an offset spacer off here to lift it up off the board to make it go through the case more, so that they stick up through. And I need to solder the chip. So those are the last 2. Chip's been pushed in already. I think we'll start with the 7-segment displays. And these need to be trimmed when we're done. Down flush. They stick up a lot. They're really tight in here. But I think I'll cut these as I go in. to wear safety glasses when you do this. I have glasses on. So, okay. Now I'm going to hit some of these again. And just redistribute the solder. It will kind of clean it up a little bit. Okay. On this kit also, they provide a FTDI header so you could reprogram the chip and put on another version, change their code around to change the functionality of the calculator, I guess. I wasn't planning on doing it, but I think I might try to put a header on. Otherwise I'll have to take it apart. And I don't know if the header sticks out of the case or not, so that's the only reason I may not do it. Battery goes up here, and of course it sticks out of the case, so you can put a battery in without taking it apart. Okay. Okay. Turn my iron up a little bit more. Let's see here. These are tight in there, right? This is the only tip I have for this soldering station. It's a little bit of finesse, you can get them. They're not too tough that you can't. You know? Okay, so we have the first three done. And you want to make sure that this is pushed all the way down flush against the board before you started. If I didn't say that, I have mine taped, so it should be level and everything. There shouldn't be crooked. Okay, so I think I can do these without. Just put the solder in, keep the soldering iron at the same angle. Just rotate the board. That way I can speed this up for you guys. Okay. Another thing, these pads are kind of small. I guess they're just adequate for what we're doing here. These 7 segments, but so you don't want to put too much solder on the joint right here. Otherwise you're gonna have a problem because these are really tight together. Okay. Let me cut these off. I'll clean up any solder connections if there is any. And then we'll do the 328 at Mega, what they have on the Uno boards. Got a couple sticking to the get out of there. Get out of there. Okay. So now let's just check to make sure we got them all. That they're roughly all the same length. I'll just dress up some of these joints here. And remove any excess solder. Okay. So I could take this off. So these are all flat, square to each other. Decimal points at the bottom. This is the bottom of the calculator. This is the top. Make sure that they're all nice in there. And then here's the, right here is the clear plastic. You don't forget to put that in, that this does elevate some, like I said. Okay. Make sure that is down. Actually, let's see. This it needs to be just soldered in flat, so it goes just like this. So what I'll do is I'll put it down, kind of center it, put a little bit of solder on my soldering iron, just kind of hold it there, and then I will go over to this other side and make sure it has the right area, and I'll hit this with all the solder that I need to. This is a mechanical joint also, not just the ground, but it is, when you slide the battery in, you're going to make sure that you have enough solder on this pad right here. If you don't, then this will get loose after a while. And the positive obviously is in the inside. So then I come back through here and hit this with solder, and I'll show you what it looks like. Right here, you can see how it soldered it in. Perfect. Both sides. So that's ready to go. So as far as the actual calculator, it's pretty much done. The only thing you have left to do is solder this in. Have these 10K resistors in. Everything else soldered. You probably put a battery in. Just check it out. Make sure we don't have any problems with the connections. I'll just check the solder joints one more time. Alright, so I'm gonna just take these. The way I usually do is just like this. Make sure I'm on camera. Is just go like this. You just run down them. This doesn't have any socket or anything, so you want to make sure that you do it fast. You don't want any chance of burning up the chip, which is pre-programmed. And of course, if you did, you'd have to desolder this out, put another one in, and then program it with their sketch code to get back to where you were. But I don't know that they sell it with this chip with their code in it with this kit. These are really nice pads. They're right size. Fit in there really good. Okay, so the chip is not hot. The other thing is, if you're new to this and don't understand what this is, pin 1 is right here. Okay, let me show you with the pencil. So we have pin 1 here. There's a little circle, half circle here, and it has to meet on this board the same. So this will have to do the same, facing the same way. Like I said, these don't have any polarity. These don't. These do, but obviously the decimal point's at the bottom of a calculator, so it's a dead giveaway. So let me get my solder. I drop. Now let me check out these solder joints one last time. Make sure that they're good. I got one here I want to dress up, and nothing's touching. Everything has a fair amount of solder, and there's no bad connections, weak joints. The computer chip is okay, so make sure you get these out of here so they don't short anything out, these little pieces. Okay. I got another. I don't have a brush. Where's my brush? Let's give this board a once over. Make sure there's nothing in there. That looks like another one here. Okay. Comes with a battery. You need a CR123 battery that it comes with. These are for the case it comes with. Just leave those there. I keep these bags. They're big good places to put things in for different components. So the positive's on top. So just plug it in. It says the calculator, the firmware version. You hit it once and it goes into the calculator, and you just make sure that you see down here when you put the case together, the buttons, make sure that they align. So you make sure you just push in. You have 6 positive and I think 5 negative numbers that you can do. This processor doesn't have a crystal on here. It's running at the internal clock frequencies, and you just, it's a regular calculator. So I'm sure that it doesn't, like do 2 times 2 equals 4. Simple things. It's not a high-tech, calculator. We have divide, multiply, minus, plus. Of course, you have equals, decimal point, and then 0 through 9. And then this is the clear and the on button. After 20 seconds, this will shut off like it just did right now. So it's off now until you hit this button again, and it comes back on. So let's take this battery out. Let's see here. Need a little. Okay. The other thing is, if you want more resistance, you can just push on these. That'll give more resistance to the battery. When you plug it in, it'll have more tension. Okay, so that's the kit. Now, this is empty of all the electronic stuff. This is empty. Now we have left is the screws, and these are the buttons. Let's move that aside and I'll turn the soldering iron off. Now, this is laser cut acrylic. I have this old eyeglass case. Here's the pieces for the acrylic case, and what I'm going to do is slightly clean them and hopefully not scratch them, because acrylic, let's face it, will scratch real easily if you don't take care of it. Okay, so we have a thick 1/8 inch front bezel. We have the back, which is 1/16 of an inch thick. We have a 1/16 of an inch thick. This is a button retainer piece, so we have that. And then these are the spacers for the circuit board, and the same sizes. You have 1/16 and you have the 1/8. And this is all these pieces I took off. Had this blue plastic on it, so everything came with the blue plastic, and a lot of the what am I thinking? A lot of the buttons all had to be dealt with. These buttons, these are all laser cut. Both sides of these, which I assembled already. This has a 1/16 of an inch plastic piece. This is what retains the button, and this had a piece, so you can see that it's flat with the pieces that were cut are flat, and the piece originally had this shiny part. So all this had to be taken apart. These had to be set inside, and then the case put together so that everything was perfectly aligned. What you wanted to do is line these up in here, put the case together. It's really time consuming. That's why I wanted to get it done now. This is just basic assembly. So let's move these buttons out. But it's all said on their instructions on how to do it. Just kind of give this a little once over. It's obviously going to get scratched as you use it. This piece you don't really see, but I want to hit it over with this. Hit it with this towel. That looks good. And I'm not going to do anything to these little pieces here. They're not worth the time. So let's put this down. Okay. We have the front, so this will be the way you look at it. And I looked this up once, so I want to make sure I don't forget. But this is the button. So this is the pieces that go in, these pieces go in here, and this is the retainer, which is smaller. So you just put those together, and then you can drop in the buttons, and they won't fall through because there's a little bit of an area here. So now I need to use painter's tape and put these two together. There's a couple spots so that it holds it together. Let's see. Do here. Okay. Do here. Okay, so this is the way it will go. Let me put a couple more pieces on the side, because unfortunately this is too big. And this is, anything low tack is good. You don't want to leave any residue. This will only be on for a little bit. Okay. And it's just doesn't have to be stay perfectly aligned. Just doesn't, you don't want it to fall apart. Okay, so I need to have this over here as a reference. Let's lay out our buttons. And here's the first one. Let's do this one. This is the clear button. So we put that one in. And we have the next buttons will be 7, 8, 9, and divide. So we need 7. Oh, sorry, 7 goes on the. Make sure it's pointing down. 7. And this is 8. And we have a 6 and a 9, but this will obviously be the 9 because I'll turn it upside down. Okay. And the divide symbol right here. So what you end up getting, yep, that'll work. And the next ones are multiply. So let's look for an X. Here's the multiply. Put multiply in. And we need 6. 6 and a 5. And a 4. Here's the 4. Just make sure I'm doing this right. 5, 4, 5, 6, multiply, yeah. Because it's in backwards order to me looking at it. We need a minus sign. So this is the minus. We need a 3. So this will be a 3. And a 2. And the 1. Okay, now we need a plus symbol. And equals. Then you need the period sign and the 0. Okay. Let's make sure these are pushed in. Let's see here, go do that. Okay. We have, okay, I did the wrong one. Very easy to get mixed up. Okay, we need 0 on this side, then the period, and the period's offset, so you have to put the period so it's closer to the bottom, and the equals, and the plus. Okay, let's make sure. Okay, so we have the 0, we have the period, the equal, the plus, and I did the wrong ones on the bottom. Second one up. So I need to take these out. I did them right the first time. It's even more crucial the first time because you're, well, it doesn't really matter because you end up having to take it apart. But when they do that step of putting these black pieces on with these clear pieces, then they expect you to continue to build the calculator. So so this should be the plus on the side, so the minus is on the first one. Here's the minus. So that's the minus. And then the 3. Oh, I just dropped it. Okay. Then the 3. There, just like that. Okay. And the next one is the 2 and the 1. Now, hopefully I did it right. 0 minus period equals plus minus 3. Say 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus minus times and divide and on off. I think that's it. Okay. Now, the next thing they want you to do is you have to assemble the circuit board offset so that the circuit board has the special room for it. And this tape, I messed it up. It left a little residue and it shouldn't have. So that should be alright. Okay, so these are in. And these will be what pushes on this part. So this will go in, but we need to put the offset. And there's 2 different thicknesses. There's we need the 3/16, or sorry, I think it's 1/8. No, it's 3/16. I think. And this one goes right here. Now I'll take out the screws and feed them up through the top with this tape still in place. Okay, come on. Tape's in the way. Okay. These are going to fall out. This is very tedious to do. To have, what is it, 17 buttons not fall out. And these screws don't have any, they get screwed into the back plate, so there's nothing in, but they just go right through. Also, I forgot to say anything. These holes all have to be pushed. The pieces have to be pushed out of them. That's the cutouts. So what worked for me was a little screwdriver for like an eyeglasses, something really small, and you just poke them right through. Okay, come on. Okay. So now we need these offset pieces. This has 3 for this, so we put this one here. Okay. And this is where the space is, because it gives room for you to get in for the battery. And then this one goes here. Okay. And then this one is keyed. It goes right in between these two on the bottom. Then the next thing that you need to put in, I believe, is this. I don't have the instructions up in front, so I believe this is the way it goes from what I remember reading yesterday. Push this through. And I'll let the screws fall out. Okay, I did it wrong. I have them backwards because it's facing the wrong way. The battery, she's hitting it. I dropped the screw. Where did you go? Let's see here. Here it is. These go the other way around. So this one goes over here. This one goes on this side. And then this goes there. And then this goes like that. Alright. I tell you what, you gotta keep your teeth just straight. Okay. Push these tapes over to hold that. This needs to be set so it's aligned. And the heads of the screws are pushed through so that they look, you can see them through the top. Okay. Hitting all the buttons. Okay. See, and this is our gap for the battery right here. Okay. Now, let's remove this tape temporarily. Okay, now we have what these are for, and these two pieces are the same on either side. And am I missing one? I might be missing one of these. I don't see it. Huh. Oh, you know what? This one goes here. It's not in any of these. These are the pads for the feet. It's a bigger piece. I don't know where it is. Let's pretend it's there. Because after that is done, there's another piece that covers up this, and then this gets screwed on and you're done. Okay, so let me look under here. I'm pretty sure that I have it somewhere. It might have fallen out. Well, that's a bummer. I have to look for it now. But basically what it does is it covers up this. These offsets allow you to not have a problem with the solder pieces. And that's pretty much it. You just screw these in. Let me push this down so I can turn it over to show you what it looks like. These screws want to come out until you screw it in. So that's it. So this is flush with the top. You get to see everything. And this is the Spikenzielabs kit. It's a calculator kit. It just came out not that long ago. And Adafruit Industries carries it. I prefer to, it's the exact same price pretty much. I prefer to get everything from them. And that's pretty much the kit. Take this tape off, screw these in after I find that piece, and you've got yourself a cute little basic calculator that you could take with you, and it's entertaining, so you can show everybody, hey, look what I built, look what makes it work, and you can tell them what you learned when you put the kit together. And yeah, that's your basic kit. So I think that's pretty much it. I don't know anything else to tell you about it other than you know, it's all open source. You can do anything you want with it and change the code using these headers that are right here. And if you want to use those headers, you can I guess you can cut this piece out a little bit and then or put something through. You can, you know, modify it somehow to get these out, so you can just plug in the cable and you can do whatever it takes to, you know, to modify it. You know, I don't plan on doing it if it requires a little effort, because I really don't plan on modifying the source code. And yeah, very cool. Battery slips right in right here. Very easy. Just turn it on. And there you go. So you can see it's nice. There's a red LEDs, and that is your basic kit. I think what I'll do is I'll finish it up, and maybe I'll do a supplemental video with you know, showing it completely put together and stuff. Alrighty, that's it. Hope you enjoyed, and I have some other things I want to cover, you know, as far as electronics, but I'm going to do some other videos. Some of the products that I've bought from countycom.com. So yeah, I'll be doing those probably pretty shortly. But this is a webcam, so the video is going to be a little weird looking, I think, on the screen. But for the most part, it's good for like hands-free stuff. So I don't have a tripod set up for my camera right now. So all right, talk to you later. Bye.